report, that was,
What?
you mentioned a British report?
Rappaport.
Rappaport, that was the one. that-
Rappaport report.
Rappaport report.
Historical discussion.
You can look it up.
When is this event taking place in Seattle?
Wednesday the 24th. Our part of it is Wednesday the 24th.
The reason they thought the way they did and how that applies to today's development.
Will it be on you?
These huge breakthroughs in science that are being reported. Like,
Okay, yeah, I was gonna bring that up.
The whole Collider program, and then there's these magnetic waves.
Okay,
that just-
I was having a discussion with Dr. was saying earlier about the gravity waves, and I thought I should have you
You heard about this?
and tell people what the significance of this is, because it's very significant.
Well,
They just
it is very significant.
detected gravity waves.
Quiet, guys.
in two aspects, actually. First one related to the general relativity of Einstein that was put forward in 1916, I think.
69?
About 100 years ago.
All right.
And in that theory, he considered the space is not just empty. You can imagine that if space is in 2 dimensions only, not 3, then heavy object inside the space will shape it. And the example he used to explain this concept is that if you have a bed sheet held from the 4 corners, and then you put a big object in the middle of it, like I say, a bowling ball. And then you put a small ball at the edge. So that ball is going to move down, following the shape of the sheet until it hits the big ball. So this way, this is actually demonstrating that gravity is not based on a force, to object having a force of the way Newton proposed. So space is shaped. It's not just, it's a flat if there is nobody, if nothing is in it. Once you put something in it, then it will be shaped. The idea that the space can be curved was proven shortly after the relativity, general relativity came out by observing a position of a star at night. Every day you can look at a specific star and measure its position. And then you wait until there will be a sun eclipse. At night, the sun is away. So we are seeing the star directly without the effect of the sun. During a sun eclipse, you observe the position of the same star. Now that position will be affected by the sun.
Right.
So there will be difference in the position from measurement at night and measurement during an eclipse. And they measure the difference in degrees and find it exactly the same as predicted by the general theory of relativity. That was done a long time ago.
So you're saying the light was bent by gravity?
Yes.
Pardon me?
The light was being bent by the gravity?
That's right, yes.
Yeah.
Well, actually, it's by gravity, but it's really basically following again the curvature of space.
Right. So the light's not bending. It's
So this is the whole thing.
yeah. Right.
Now, if space can be formed or distorted by heavy objects, then if that heavy object moves, then space will have ripples in it. The same way when you have a lake, calm lake, the water is steady, and then you drop something in it. Then you get the ripples going through. So the same thing should happen in space as well. But that will require an extremely large object. So recently they have been observing 2 black holes with huge mass that they are moving around each other. So moving around each other, they disturb the space, and they were expecting to see the ripples coming to the ground here. By the time they come to us, it will be extremely small, very small distance, up and down. So that's why it was a very difficult experiment to do. So they have been working on it, I think, for the past 10 years. And finally, they were able to eliminate all other background and any other effects. It's a very complicated experiment. And eventually they claim that they have a proof now that they have seen the ripples coming from these 2 black holes.
Using laser measurements on a T
Using
formation.
laser and mirrors that are suspended, that not affected by any other thing. Details are too much. So now, since there is these waves, gravitational waves, that has been predicted long time ago but hasn't been observed. So now this is actually a confirmation again that space is actually behaving like water, for example.
Yeah.
And the fact that gravity has waves, it has another impact, that quantum mechanics and the general theory of relativity that predicts curvature of space and all of that cannot be matched together. So you have quantum mechanics that explains what's happening inside the atoms and subatomic particles. And you have the general relativity that explains the structure of the universe. And these two cannot be put together. So the physicists believe, and I agree with them too, that these two theories has to come together. You cannot have one rule for the small and another rule for the big, and these two.
Well, right now these
That's what
theories
Einstein said,
don't, they don't jive, they don't coincide, they don't complement each other.
Right now they are completely separate.
Okay.
You cannot go
The grand
from one to the
unification theory, right?
other. Yeah, well, the string theory is supposed to
Yeah.
do that, but the problem, there are lots of problems with string theory. Let's
Can't
not get
prove
into
it.
that
Go
one. So the point is that at a certain point, some physicists are saying that stop trying to match relativity with quantum mechanics. Maybe this is the way it is.
Yes.
That nature is set up that way. That set of rules will apply to the small, and another set of rules apply to the big, and they cannot match to each other. The existence of gravity waves is saying that this concept or this view is wrong.
Right.
Because once there is waves, quantum mechanics also deals with waves. Then they have to be. So the idea that now people can try to match the two theories together, although a very tough topic, but I think that will be now have some motivation to continue and try to match the two theories together. So you have two impacts now. The first impact is to prove Einstein's concept of space. Actually, he said space and time together, not space only. But that's, we have decided.
But it also proves space has like a fabric, or it has a substance to it. If there's a reaction of a ripple going outward, then space is not empty. It's obviously
Space is not empty.
it's composed of
Right,
something.
right.
Actually, there is, again, to go to quantum mechanics saying that vacuum actually can erupt and produce particles
Right.
from
Well,
vacuum.
say that again. The vacuum what?
Vacuum can actually
Produce particles.
erupt and produce two
Okay.
particles, two opposite particle antiparticle thing.
Don't get
But
the
the point
idea.
is that the idea that the space is nothing, that was all the thing during Newton's time and Maxwell's and all of these people, that this space is not really just nothing. It has fabric, it can be affected by object in it, and that explains the gravity. And it actually also shows that this idea of a force at a distance is not really true. You don't have a force at a distance. However, quantum mechanics has something in it now that might show that there is actually a force at a distance, but that's another issue. We can talk about that some other time. So the important thing is that the concept of space-time has a fabric in it, and it can be distorted by big objects. It's confirmed. And the second one is the link between quantum mechanics and relativity need to be pursued. And
At this point, they're in conflict.
But this might open a door.
But, you see, this gravity wave theory is based on the concept of a black hole, which itself is just a theory. It's much more easily explained in plasma physics. A high concentration of mass is much easily conceived in plasma physics. And black holes theoretically rotating around itself, it's natural in plasma physics, in rotating Birkeland currents. It's nothing new. So we're talking about a universe that has been divorced of 99% of itself, according to physicists at the at the Los Angeles National Laboratory. 99.999% of the mass of the universe is in plasma form. So why do we ignore plasma as a factor in cosmology? So we get into theories that contradict what we know. That's why we get into this confounding, you know.
This gravitational waves have nothing to do with how and why black holes are formed. This is another issue completely.
But,
You have two black holes, it doesn't matter how they are formed. They are moving around and they are affecting the space around it. I mean, that was a theory, but not anymore. The experiment done, if this experiment is correct, if it is the very first measurements, and I'm sure it has to be done again to confirm it.
Yeah.
But if this experiment is confirmed that we are actually seeing the ripples in the space fabric from these two black holes, then it's real. It's not a theory anymore. Okay.
But I guess he's referring to the
black holes,
structure.
why the black holes are formed and how, whether the space is plasma or not a plasma,
Right.
this is beside the issue now.
Yeah.
But plasma also has electric field effects, which could be just as well causing the ripples that
No.
you're seeing.
No. The plasma ripples, these are electromagnetic.
Yeah.
Electromagnetic is different. These waves they are talking about, these are mechanical waves.
Well,
Physical
Physical waves.
effects have
Mechanical waves are different from electromagnetic waves.
Yeah.
And scientists know very well how to separate these two.
It was all isolated, yeah.
One of the experiments, one of the things that's been done in this experiment is to avoid any kind of waves, any other kind of waves that exist, and only concentrate on what's coming from these two black holes. So that has nothing to do with whatever the space is plasma or not. This is another issue. We can talk about that later on. But this is proving that there is a mechanical wave coming from these two objects. The other step is that they are going to try to detect the gravitational wave that actually came from the original Big Bang. But that hasn't been done yet. But these are some of the
which is
future
another
things
first
they are
theory.
going to do. Whether it's the BigAng happens or not, that's another issue again.
I think
let's not-
gravity
yeah, let's
waves
not-
also travel at the speed of light, I think, correct?
I'm sorry?
The gravity waves also travel at the speed of light, I think.
Yeah, that's a question. That's a question I had.
Electromagnetic waves will
So
be following the speed of light, but I don't think gravitational waves will move with the speed of light. I'm
That's
not
our
sure
question.
actually on this.
Okay, hang on.
I think that's
We
what
got
I
an
read.
order here, so share your.
Thank you. Can we go over the sheet thing again?
Yes.
I don't understand it because I don't understand what you mean by space. So is it outer space or the space between, like, that's within this?
Can I say, what emerged in the period of Newton and beyond until Einstein was that space itself was just space. It didn't have any, it wasn't a substance, it wasn't
So space as in, what does that mean?
it means it has no substance. That things are
What
in
is
space.
What is space? Is space, what is space?
No, like outer space.
This is a
Outer
concept,
space?
outer space, inner space, the space between you and me, the
Space.
space between molecules,
Space anywhere.
whatever, any space.
Okay,
Space was not a substance,
okay,
okay?
yeah.
It didn't have,
Okay, that's my.
okay, that's the
Yeah,
difference, that's the
yeah.
difference, yeah.
And the sheet thing, if you could just go over the sheet thing, just one more time. So you're holding the four corners,
Anybody?
Yeah, you
and
hold
that
it,
is.
Yeah, for everyone.
you hold it from the four corners,
Yeah,
Bowling ball in the center.
and then you put something heavy in the middle.
and the sheet represents what?
Then the sheet represents space, two-dimensional space.
Okay.
Okay.
yeah.
Two-dimensional.
So now the heavy object in the middle is going to push to actually make the sheet take a special
Curve.
curve. Once you put an object here and let it go, it's going to move along the
That
shape
curve.
of the sheet.
Yeah.
That to show that
Space is curved.
the gravity
Space has
is not a
substance.
force between the two objects. It's actually moving any space shaped by the heavy object.
And before, it
So
was
this is a
believed,
theory, was a theory?
That was the Einstein theory,
Was-
yes.
Okay.
okay, and before, it was assumed that,
Two objects
the two objects were
interacting.
actually attracting each other by an inverse,
That's not the
Yeah.
case.
yeah. This is big.
It's huge.
So now, on this example here, that are assuming that Earth gravity doesn't exist. Let's assume that. If there is no Earth gravity or any other gravity, then this shows that the particle behaves as if it is in a gravitational field similar to the one proposed by Newton. So, another way of explaining why when you let an object free, it falls to the ground. It's not fall to the ground because there is a force acting on it, but because it's following the shape of space by the Earth and the Sun and all of these big objects.
Wow.
So this changes all of the concepts of what we thought before, but I just want to ask you one question.
Okay.
When this news broke,
see the 3D, but I can't see.
yeah, on Facebook, a lot of physicists came out on Facebook and were attacking this experiment and this finding like viciously. And are these quantum physics mechanics that are upset that maybe their field might be being disproven, or why is there such a vicious attack upon Einstein and upon this experiment?
That happens all the time.
Thank you.
That happens all the time. Whenever you have a new thing coming,
Yes.
you will always have people attacking it. This actually is not a bad thing.
No, it's
a healthy thing.
Yeah,
it's bad because 2 years ago, there was an experiment done in CERN that showed that there are particles that can move faster than the speed of light.
Right.
And again, the attacks are coming from all over the place. It turned out that the experiment was wrong. They repeated the experiment again and came back and said, sorry, we had screwed up in one part of the experiment, and when we repeat again, it turned out that those particles are not actually moving faster than the speed of light. So it is healthy to have people criticizing it, so that remember, this is the first measurement.
Yes.
You need to repeat that again several times so that it can be confirmed as a real fact.
All right, go ahead.
In the old days, they would have been taken and tortured until they retracted.
Maybe that's what happened.
Take it back.
You can probably do that in the Vatican.
All right.
I got lots of. Excuse my.
Well, we can move on to something else if you want. Go ahead.
Excuse my ignorant concern, but my understanding that black hole is always in the middle of the galaxy, or it can either exist anywhere in space without objects around, or.
I'm not really an expert on black holes. But my understanding is that because it's so massive, that it behaves like the sun. The sun is so massive, so the other planets are rotating around. So if you imagine something that is millions or billions of times more massive than the sun, then the whole galaxy can rotate around.
Would be affected by it.
There is, however, the theory on black holes have been evolving. It was assumed at the beginning that it's a mathematical issue, but that's not anymore. People are starting to modify their idea about the black holes, how they are formed, and how strong they are, and all of that. So the theory of the black holes is still evolving. It's not really final.
Okay. I would have to second that the gravity is a push force or a pull force. There is a difference in that. You have a definition for that. Gravity being a pull force instead of, a push force instead of a pull.
But this is that Newton's assumption was that any two objects will attract each other. That actually assumption is not based on any basis except that observation. He was able to explain the observation by this assumption, and it worked very well actually.
That was based on observation, right?
Yeah. So Einstein said that this distance, force at a distance doesn't make sense. It needs to be explained in a different way, and he explained it by the gravitational waves.
All right, I really appreciate that.
By the way, there is a proof there is a black
really,
hole
thank
in
you.
Wall Street.
That really helps.
That is for
That
real.
really helps. Okay.
About-
All the money gets sucked in.
It's called
I
derivatives.
don't think
I can't
this
disprove
role
It's
can
a green
actually
hole.
materialize using fossil fuels. Fossil fuels have reached the same stage as coal right after the industrial revolution. And then, I'm sorry, the coal. For after that, we need to move into oil.
Yeah.
And right now, you cannot have these trains, fast trains moving all over the world using oil or natural gas. The infrastructure for having oil and natural gas feeding those trains is humongous.
Yeah.
The only way to do it is that these trains has to be electric trains and supplied by nuclear power. Without that, forget it. It's couldn't happen.
Do the Chinese understand this?
I don't know.
But that's the question. That's the big question. Do the Chinese understand that they can't do the thing without nuclear power?
I think they know,
What'd you say?
I think they know. From what I know about, China has an industry that produces nuclear power systems. It's not just small scale in China. I don't know where that industry is located, but that's what I hear. They're building nuclear power plants, industrial type process, and not just piecemeal. So they're committed to this.
But that's, okay.
I just wanted to anecdotally talk to you about Chinese development. I come from a small community, I lived in for 25 years, and the Chinese representative, this is in explaining how they think about development, showed up in the little town of Bellacoola and said, we've decided to go logging in China in the northern regions. You guys are the center of logging, and you know, we'd like you to teach us about it and provide some equipment. And so, okay, how much equipment are you going to need, you know? And the guy says, well, we need 350 Medill towers. And the guy says, 350 Medill towers? The whole production run in North America wasn't 300 towers. So they were thinking on a level of purchasing more towers than had been produced in North America for all of the logging. If that gives you any perspective on the way that they were thinking.
What are those towers?
They're a huge tower they set up with guy lines and everything else, and then they have a back anchor, and they run the chokers out and run a pulley system out over a setting, then they hook up the logs and pull them back into a landing. And they're quite intensive labor-wise, but they're very efficient. But they said, well, we can maybe sell you 10, you know, but there wasn't 300 made in the last 50 years. So that this gives you a perspective on how they think about development.
Well, in addition to that, the trees are not the size that they
They're
are
quite small.
on the coast. They're small trees.
That's
I would
right.
think, because, you know, we had some experience in northern China too. And,
Yes.
you know, they were very keen on getting all those equipment.
Yeah, no, it was quite hilarious.
So the general relativity of Einstein that was put forward in 1916, I think.
69?
About 100 years ago.
Oh,
And in that theory, he considered the space is not just empty. You can imagine that if space is in 2 dimensions only, not 3, then heavy object inside the space, will shape it.
Program, and then there's these magnetic waves.
Okay,
that just-
I was having a discussion, what Doctor was saying earlier about the gravity waves. And I thought I should have you
You heard about this?
tell people what the significance of this is. Because it's very significant.
it is.
Well,
He just
it is very significant
the gravity wave.
Quiet, guys.
in 2 aspects, actually. First one related to
Report, that was,
What?
you mentioned a British report,
Rappaport.
It was,
Rappaport, that was the one.
Rappaport report.
Rappaport
it was
report.
historical discussion.
You can look it up.
Between
When is this event taking place in Seattle?
Wednesday the 24th. Our part of it is Wednesday the 24th.
The reason they thought the way they did and how that applies to today's development.
Will it be on
These
YouTube?
huge breakthroughs in science that are being reported.
Okay, yeah, I was gonna bring that up.
The Collider program.
that gravity is not based on a force two objects having a force of the way Newton proposed. So space is shaped. It's not just, it's a flat if there is nobody, if nothing is in it. Once you put something in it, then it will be shaped. The idea that the space can be curved was proven shortly after the general relativity came out. And the example he used to explain this concept is that if you have a bed sheet held from the four corners, and then you put a big object in the middle of it, like I say, a bowling ball. And then you put a small ball at the edge. So that ball is going to move down following the shape of the sheet until it hits the big ball. So this way, this is actually demonstrating